Good morning, Hamilton County 4th graders. Alright, so hopefully you've already seen the introduction to our lesson. If not, you need to go back, go through the instructional video, and get that math journal out and get those notes down. So today is week 4, day 3. We're done with line plots. We're going into angles, starting with instructional page 300. Woo. Those are my manipulatives for our video today. Alright. So. Hang on. Katie?
What?
Get away from the sink.
Okay.
We've got Miss Katie Bug here with us today. Do you want to say hi?
Yes.
Her daddy is working, and so she is joining us. Don't mind her hair. She's been running wild all morning. Come on. Come up here so they can see you. There. There she is. If you hear noise in the background, that is because of her. What are you doing? Alright. Nope. Nope, 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 nope. Nope. You don't get to draw with Mama stuff. Alright, thank you. Go on. Apparently, my cat is in here. Guys, really? Go. Go, 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 go. No, I have to do this now. The kid, everybody, let's go. Go, go, go.
Wait, Mark, are you bored?
Go potty.
Okay.
Yep, that way.
Okay.
I regret that decision to have her say hi. She went a little crazy there for a second, and I did not know the cat was in here. Leo. Leo. Come here. Oh my God, you can't go back there. You're going to get stuck. Rah. This is Leo. Yeah. Yeah. Hi, Leo. You gotta go. I know you don't want to, but you gotta go. I gotta work. Okay. Now, back to page 300 in the instructional book, angles. So, we're gonna think it through. What is an angle? Squares, rectangles, and circles are geometric shapes, as we know. An angle is another type of geometric shape, as we talked about in the instructional video. You did not go, and you need to go now. Suppose you have two pencils lying straight across the table. You could put the erasers together to give the pencils a common endpoint. Then, if you turned one pencil until its point straight up, you would form a right angle. So, this is where the manipulatives come out, guys. So if you have two pencils in front of you, there we go, two pencils in front of you, go ahead and get them out. Let's play with it for a second and figure out what they're talking about. So, here's my one pencil, and it's saying, suppose you have two pencils lying straight across a table. So just like this. The lines aren't that even, but okay. Come on, work with me. Work with me. Focus. There it goes. So, I have two pencils, and they're lying next to each other. They said that you can put the pencils together at the erasers and create an endpoint. An endpoint is the same thing as a vertex. It's where two lines or rays or line segments meet at an angle. So here's our vertex. And what we just made right here is what is called a 90-degree angle. If we moved the pencils so they were smaller, like this, we no longer have, I hate that it's deciding to do that today. There it goes. So now we have an angle that is less than 90 degrees. What do we call that kind of angle? an acute angle, meaning it is less than 90 degrees. But what if we took our endpoints and I moved it back up to my 90-degree angle, my right angle, because my right angles are always 90 degrees, and I went this way with it? What kind of angle do I have now? Is that angle still 90 degrees as it goes in and out? Come on, document camera. Work with me today. Anyways, is that angle 90 degrees? No, it's bigger than 90 degrees, and so it's not acute, it's not right, it's obtuse. Alright, so back to our workbook. If it'll let me alright.
Mom, I found a tangled flower.
Y'all hang on just a second. Let me... Alright. Sorry about that. I had to take care of the child. Hopefully you guys are not giving your parents as hard of a time as my child is giving me today. So, we were playing around with angles with pencils. Hang on. The phones. The phones. Anywho, this is going to be like the longest video ever if I keep getting interrupted. Anywho, so we were playing with our pencils and we were saying that if we treated our erasers like our vertex and we moved the pencils like so, we can create different angles. Like we had a 90-degree right angle. We had an angle that was less than 90 degrees, making it acute. And then we had an angle that was obtuse. If we were to trace, like if we were to keep going clockwise like this, and we keep going, and we keep going, you notice how we're forming different angles as we go. And then we finally end up meeting right back at the beginning of our circle. So when we go all the way clockwise with our angles, like so, we create a 360-degree circle. Now, think about the way a second hand travels around the face of a clock. It turns the same small amount each second. Imagine that you move the pencil like a second hand, except that you make each move so small that it takes 360 turns to go around the full circle. Each turn is an angle that measures 1 degree. So if we were going to think about it like that, say that this smaller pencil is going to be my seconds hand on a clock. Alright? If I were to go, and the way that a second hand moves, it goes 1 tick at a time, right? Well, what if I were to tell you if a whole clock's face is 360 degrees, each time that second hand moves is the same as 1 degree. This would be 1 degree angle. And as it moves at a 1 degree angle. Each time it moves, it adds 1 degree to the original. So if this is 0, or well, since it's flat, it's really a 180-degree angle, we go, that's 1 degree, 2 degree, 3 degree, 4 degree, or 1 second, 2 second, 3 second, 4 second. The size of the clock face and the length of the hands do not change the measure of the angle. The measure of the angle describes how wide the angle is open. So when we talk about the measure of an angle, it's just talking about how wide it is right here, not how long the lines connecting the angle are, but how wide it actually is. So let's look at the reflection. Number 1 says describe and compare the circles and angles in the clocks below. Well, let's look at this first clock. So this is the hour hand and this is the minute hand. These are two rays, and they meet in the middle at a vertex. So these two hands are actually forming an angle. Now let's look at that angle. Do you think that that angle is like a right angle where it's 90 degrees? Do you think it is a small angle less than 90 degrees? Or do you think it's a large angle that is more than 90 degrees? I would say this looks more like an obtuse angle. I would also say that this angle over here is less than 90 degrees, meaning this would be an acute angle. So what we could write is the circle on the right over here, because it says describe and compare the circles. So the circles themselves, the circle on the right is what size compared to the other circle, the other clock? It's bigger, isn't it? So the circle on the right is bigger. The angle formed by its hand, though, the angle that's formed by the hands is acute. The angle formed by its hands is acute, meaning it's going to be less than 90 degrees. The angle has a smaller measure than the angle formed by the hands on the clock, on the hands on the 8 o'clock. So we had, hang on, go. I mean it, Katie. Oh my goodness, she's going to drive me insane. So, trying to regain my train of thought. The circle on the right is bigger. The angle formed by its hands is smaller. The clock on the left, or the circle on the left, is smaller, but the angle formed by its hands is larger. Just like that. So all we're doing today is really learning excuse me, how to visualize these angles, and without measuring them, know that this is a 90-degree angle, this is an acute angle, this is an obtuse angle. So let's take what we know and take it to the practice page. Page 303 in the practice book says, 4 friends shared a whole pizza. Each person ate an equal amount. Draw lines on the circle at the right to show the fraction of the pizza that each person ate. And they already did that for us. So not only does Earth rotate at an angle, not only do our clocks form angles, but pizzas form angles too. Angles are everywhere, guys. So they drew lines through the pizza to cut it into fourths because we had 4 friends that were eating it. It said use multiplication to show that 4 parts together equal a whole. And then all they did was they did simple fraction multiplication. We had 4 sections of a fourth, so we did 4 times a fourth. All we did here was we put a 1 under the 4. Remember back when we were really working with fractions, when we have a whole number, we can assume that there's a 1 below it. So like if I had 3 and I wanted to add it to, let's say, well, let's not even look at adding. If I just had the number 3, remember fractions are just a way to represent division. And so if I wanted to represent this 3 as a fraction, I can represent it as a a division problem. 3 divided by 1 is the same as 3, because 3 divided by 1 equals 3. So when they multiplied it out, they did 4 times 1, and they got 4, and 1 times 4, and they got 4/4, which is the same as 1 whole. Number 1, 8 friends shared a pizza. So now we have 8 friends. Each person ate an equal amount. Draw lines on the circle at the right to show the fraction of the pizza that each person ate. So instead of working with fourths, we're going to work with eighths. So I'm going to divide my circle into fourths first, and then I'm going to go back through and I'm going to divide it again into fourths. Just like that. And we know that 4 plus 4 is 8. So I've just turned my pizza into 8 pieces of pizza. What fraction of pizza did each person eat? Well, each person ate an equal amount, so each person ate 1/8 of our whole pizza. It says use multiplication to show that all parts are equal to the whole. Well, all we need to do there is form a simple multiplication problem. 8 times 1/8, because we have 8 pieces that are equal to an eighth. And remember what I said, when we have a whole number here, we can just put a 1 under it, multiply it out. 8 times 1 is 8. 1 times 8 is 8, equals 1 whole pizza. A pizza is cut into 8 equal slices. What fraction? Are they having us redo that? They are. So same here, because our pizza is cut into 8 equal spots or parts. The fraction each person would get would be an eighth. Mandy eats 2 slices. What fraction of pizza did Mandy eat? Well, she ate 2 slices that were both 1/8 of the pizza. Multiply it out. 2 times 1 is 2. Remember, we're going to imply that there's a 1 under there. 1 times 8 is 8. We can reduce that fraction because 2 and 8 share a factor. They share the number 2. So we're going to divide 2 to the numerator and the denominator. 2 divided by 2 is 1. 2 divided by 8 is 4. 1/4. Use multiplication to explain how you found the answer to be. Well, we did 2. We can write it back out. So you would just write down exactly what you did in B. Sometimes I always go a little too far when it comes to terms with this book. I always end up talking the problem out all the way before we actually talk it out through the word problems that they provide. That's okay though. Alright, so 304. Page 304. Look at the clock at the right. When the minute hand moves from the 12 to the 3, it moves over 1/4 of a circle. We know this because we've gone, think about it, if we were to cut our clock down, that would equal 1/4 of our clock. How many minutes are in 1 hour? Well, we know that. 60 minutes are in 1 hour. When the minute hand moves from the 12 to the 3, how many minutes have passed? It says use fraction multiplication to show your answer. Well, if each one of these quarters is worth 60, then we would have, let's see, 60 times, hang on, make sure I'm doing this right. Don't quite understand where they're getting at with this. When the minute hand moves from the 12 to the 3, how many minutes have passed? Use fraction multiplication to show your answer. From 12 to 3, each one of these is worth an hour. When we move from 1 to 3, that was 4 hours, so that's where they got the quarter. So we do 1/4 times 60. Remember, we're just going to assume that that one's below there. 1 times 60 is 60. 4 times 1 is 4. And then we divide it out. 4 divided by 60. 4 goes into 6 once. We multiply it out, subtract, and we come up with 15 minutes. Now, look at the clock at the right. When the minute hand moves from 12 to 6, what fraction of the circle does it move over? So instead of going from here, we went all the way down to here. So if this was worth 1/4, if we have 2/4, we have 2/4, which is equal to 1/2. B, how many minutes have passed? Use fraction multiplication to show your answer. So we have 1/2. So instead of 1/4, we have 1/2. We're going to multiply that by 60 because each one is an hour, and an hour is worth 60 minutes. So we're going to go ahead and multiply that out. We have 60 divided by 2, which 2 times 3 is 6, so that would be 30 minutes. Look at the clock at the right. When the minute hand moves from 12 to the 4, it moves over 1/3 of a circle. How many minutes have passed? Use fraction multiplication. So we're going to do that same thing again, except instead of using 1/2, we're going to use 1/3. 1/3 times 60, because that's how many minutes are in an hour. We're going to assume that 1 below there. 60 times 1 is 60. 3 times 1 is 3. We divide it out. If 3 times 2 is 6, then 3 times 20 is 60. Or, no, that was right. Alright. Look at the clock at the right. When the minute hand moves from the 12 to the 1, how many minutes have passed? Use fraction multiplication to show your answer. So this only moved, how much did this move? It moved 1/12. If this was 1/4 and we cut this and we kept cutting this down, it would be 1/12. If we kept going, we'd end up with 12 notches. I did it up here, sorry, or all the way up here. And then we just use fraction multiplication again. 1/12 times 60. We're going to assume that 1 below there. 1 times 60 is 60. 12 times 1 is 12. 60 divided by 12 is 5 minutes. Now, you might be wondering, Miss Hotchkiss, we are not supposed to be working in time. We've already done a lesson on time and money. What does this have to do with angles? Well, it has a lot to do with angles because each time we were calculating this, we were actually looking at the angle. How open was this angle? Well, this angle was 15 minutes. So when the 3 and the 12 meet together, that's 15 minutes. This angle that started at 12 and came all the way to 6 was actually half of our circle, meaning it was 30 minutes because we know that one whole go around the clock is worth 60 minutes. Well, let's start thinking about that in terms of just circles, period. Alright? If I were to say that this is a 360-degree circle, and I split that in half, that's 180 degrees. If we think of it in terms of that, and then in terms of minutes, we would have 9 angles within this area that could be worth 30 minutes. Alright? It's a little confusing how they introduced that But basically all they're wanting you to start visualizing is those angles in clocks, angles in pizza, angles on Earth that cause our seasons, because that's what this is all about, understanding angles. So if you go back through, if I said it was 3 o'clock, what kind of angle is my clock at? It's at a right angle. If I said that it was 12:30, I could say that my angle is worth 180 degrees because it's half of my circle. Half of 360 is 180. And we can keep going. If this was a right angle, this is larger than 90 degrees, so this would be obtuse. This would be acute. Alright. So going into our countdown real quick for day 9. Missy bought 3 umbrellas and 5 hats. Oh, hang on. I don't want the other video to pause. It's technically the instructional video is still uploading as we speak. And so, did it go? Go. I'm already at 20 minutes and I have like 10 minutes on the other one. Whew, y'all are going to have to bear with the uploads today because they are going to be slow. I can already tell you that from the length of these videos. Anyhow, number 1, Missy bought 3 umbrellas and 5 hats for $27. Each umbrella cost the same amount. Each hat cost the same amount. Let's go ahead and go through. The price of a hat is $3. What is the cost of 1 umbrella? Very similar to the questions that we've been answering for this countdown. We're going to take our total amount, $27. We're going to subtract however much we spent on our hats. So we had 5 hats. Each hat cost $3. So 5 times 3 equals 15. So we subtract 15 from our total amount of money that we had. 7 minus 5 is 2. That's 1. So we have $12 left over to spend on these umbrellas after we pay for our hats. We know that we got 3 umbrellas. So I'm going to divide my money up into equal groups of 3. So 3 divided by 12, 3 goes into 12 4 times. All that evens out. That's great. So each umbrella is going to cost $4. Number 2. Anthony wants to buy the same number of hats for 6 of his friends. He has $108 and each hat costs $8. What is the largest number of hats that Anthony buys for each of his friends? So he has $108. Let's put this off to the side. He has $108. Each hat is going to cost $8. He wants to buy the same number of hats for 6 of his friends. So we're going to divide 108 by, let's do the cost of each hat. So 8 goes into 10 one time, subtract it out, bring down. 8 goes into 28. Well, we know that 8 times 2 is 16, 8 times 3 is 24, and 8 times 4 is 32. So at most, it would be 3. 8 times 3 is 24. We subtract. We have $4 remaining, but that's not going to be enough to... Come on. We have $4 remaining, but that's not even enough to buy a single hat. So we can buy 13 hats. And that would be our answer. Now, if we wanted to find out how many hats each of his friends are going to get, we would take that number again and divide it out. 6 goes into 13 twice. That's 12. And he would have 1 hat remaining. So each of his friends would at least get 2 hats. Number 3. Jenny bought 7 umbrellas and 10 hats. The umbrella costs $8 each and the hat costs $4 each. Write an equation to show the total cost in dollars of the items Jenny bought. So she bought $7, or she bought 7 umbrellas. The umbrellas cost $8 each. So we have 7 times 8. That's just the umbrellas. And we would want to add in however much she spent on the hats. Umbrellas. And then the hats, she bought 10 hats, and each hat cost $4. And we're going to close parenthesis there. And that's going to equal our cost. If we were going to solve this, we would say 7 times 8 is 56. We add in 10 times 4 would be 40. So she spent a total of $96. Number 4. Kathy is looking at an equation in her math homework. She makes 4 statements about the question. Which statement by Kathy is correct? So first she says the equation is false because the sum of 44 and 38 is not equivalent to the sum of 59 and 23. Is she right? Let's check. 8 plus 4, 8, 9, 10, 11, 12. Carry the 1, that's 7, 8. Alright, adding the other side, 3 plus 9 is 12. Carry the 1, 5, 6, 7. Well, they're equal, so the equation definitely is true. So that's not going to be right. So let's just go through here. This one's not going to, C is not going to be right either because it said it was false. Now, it says the equation is true because the sum of 44 and 38 is not equivalent to the sum. Well, that didn't make any sense. So let's hang on. Hopefully D is right. The equation is true because the sum of 44 and 38 is equivalent to the sum of 59 and 23. So D is the correct answer. Last one. Which statement is true about the equation 98 minus 12 equals m plus 20? I hate when they run off like that. I like to rewrite them. 98 minus 12 is equal to m plus 20. It says the value of m is 32 more than 98. Would that be true? If we were to take this 12, would it be the 12? I would think it'd be the 12. If we were to take this 12 and add it over here in order to make this statement true, would that work? Or wouldn't it if we were to add? And if we were to take away from it down here? Would the value of m be 12 more than 98? Or would the value of m be less than, or the value of m 12 less than 98? Pause the video for a second while you figure that out. I'm fixing to close this up real quick because this is our last problem. The answer is actually the which number did I say? I said it was B, that the value of m is 32 more than 98 because the difference between what we would have gotten here if we were to subtract this 20 and added it over here, we would have gotten 32. Alright, so that is the end of day 3, Introduction to Angles. I hope you guys got a good understanding. We're going to be working very closely with angles for the next few days, so if you do have any questions, you need to get a hold of me, talk to me, and we will work it out together. Alright? I hope you guys have a great rest of your afternoon. I hope everyone stays safe tomorrow. Please know that the videos tomorrow may be delayed until Friday due to weather. We're supposed to be getting some bad storms in, so I hope you guys stay safe, and I will